This is a problem worked through for problem number 57 in lesson 2.5, Velocity and Acceleration, Graphical Modeling and Interpretation. Now in this problem we're going to do almost exactly the same thing we did in problem 55, but in this case we need to do both a position versus time graph, and we'll use this new box over here to create a velocity versus time graph. So we'll start off by completing this first table to create our data table for time and position. So our time, we have 0 seconds, 1 second, 2, 3, and 4 seconds. And our little person is at 3, 4, 7, 11, and 19. So we'll add that information to our table. We've got 0, 1, 2, 3, and 4, and we have 3, 4, 7, 11. Actually, I take that back. That wasn't 11. That was 12. 7, 12, and 19. Now, we have to do a little bit of calculation. Now, here in the problem, it actually tells us that T mid is going to be time 1 plus time 2, and that is divided by 2. So for this box, you can see how it's kind of in the middle between this row and this row. So here we're looking for the middle point between these two values. So this would be T1, this would be T2. So if I was to just kind of scratch it out here, we would have T1 is 0, T2 is 1, we divide by 2, that gives us 0.5. For the next one down, it would be 2 plus 1 over 2. That gives us 1.5, right? 3 divided by 2. So here, 3 plus 2 is 5, so that divided by 2, that's 2.5. And this one here is 3.5. Now, for the velocity, we need to do this equation, where velocity is delta x over delta t. Now, it is a fair bit of work, but it's 4 minus 3, that's our change in x, over 1 minus 0, that's our change in t. So we have a 1 here, we have a 1 here, so our velocity is 1. Here we have a 3 and a 1, so our velocity is 3. Here, 12 minus 7 is 5, this is still a difference of 1. And then finally, 19 minus 12 is a difference of 7, and the time is still a difference of 1 second. So now we have our two tables completed. So let's move down here, and we need to create both a position time graph and a velocity time graph. So we'll start with the position time graph. Once again, as with problem 55, you need to label what you're doing. So this is position versus time. Position will be here on the vertical axis. And that's measured in meters. And time, measured in seconds, is here on the horizontal. Now, in our data table, we have 0 through 4, and then we have 3 through 19. So there are 20 squares here, so I'm just going to do 1. So this is 1, 2, 3, 4, that's 5, 6, 7, 8, 9, that's 10, that's 15, and this is 20. And then I've got 0, 1, 2, 3, and 4, with 4 spaces in between. So when time is 0, x is 3. So when time is 0, x is 3. Oh, I'll do that in a different color. When time is 1, x is 4. So here's this, we come up to 3, there's 4. When x is 2, when time is 2, x is 7. There's 5, 6, and 7. When time is 3, x is 12. So here's 3. We're going to come up this. That's 10, 11, and 12. And when time is 4, x is 19. So this right here is our position versus time graph. And we can go ahead and see that this is curving upward. So tell you what, let's go ahead and actually, while this is fresh in our heads, let's do part C, where we answer the critical questions. So for question number 1, where do we begin? Where's our initial starting point? We are here, and we are to the right of the origin. So question number 2, all right, what direction are we moving? Well, we're starting here on the right, and we are moving further right. So we're going to move right. Question number 3, is this object speeding up, slowing down, or remaining at a constant velocity? We have a curve, and we are curving up. We are increasing in speed. You can see here that the time interval is 1 second between all of these. But the vertical position change, right? We change 1 unit here, we change 3 units here, 5 units here, 7 units there. So our speed is increasing. And for question number 4, where's our final position? Where do we end up? So we started right, we ended up further right. Okay, so now let's go back and do our velocity versus time graph. So this graph is going to be done very similar to the position versus time. So we just have, our title is velocity versus time. Now, instead of having position along the vertical axis, we're going to have velocity. And this is going to be measured in meters per second. We're still going to have time as our horizontal axis, and that's measured in seconds. So now for our scale, we have 0.5, 1.5, 2.5, and 3.5 on our time scale, and then we have 1 through 7 on our vertical. So I'm going to say that we start at, well, let's see. Let's do 0.5 here, 3 marks in. So 1, 2, 3, that's 1, 1, 2, 3. So this will be 1.5, and then 1, 2, 3, 4, 5, 6. This will be 2.5, and then this one will be 3.5. Now for our vertical axis, we only have 7, so I'll just say, let's do, this is 1, and 2, 3, 4, 5, 6, and 7. All right, so at 0.5 time, our velocity is 1. So at 0.5 time, our velocity is 1. I'll do that in green. At 1.5, our velocity is 3. At 2.5, our velocity is 5. And at 3.5, our velocity is 7. Now, this is a perfectly straight line. What that means is that our acceleration is constant. So our object is accelerating at a constant rate. Now, let's determine what our rate of acceleration is. So using our velocity versus time graph, determine acceleration of the little person. Now, we're going to do this similar to velocity, except instead of solving for v, we of course are solving for a. So we have the change in velocity over the change in time. So we have VF minus VI divided by time final minus time initial. Now, we pick 2 points. I'm going to go ahead again and I'm going to pick our first point and our last point just to make things simple. So, pull this up. Our initial point, let's see, initial is 0.5 and 1. Our final is 3.5 and 7. And once again, this is time, comma, velocity. So that means that these are our velocities, final and initial, and these are our times, final and initial. All right, so let's plug our numbers in. We have 7 minus 1 on the top, and we have 3.5 minus 0.5 on the bottom. That gives us 6 over 3, which is 2. Now, units, we have velocity over time. So this is meters per second divided by seconds. So our units here are going to be meters over second squared. And that is our acceleration. And that's the problem worked through for problem number 57.